Britain is covered in untapped energy, not hidden underground, not offshore, above our heads, on millions of rooftops. Homes, warehouses, factories, schools, supermarkets. What if Britain covered every suitable roof with solar panels? Could millions of small systems quietly reshape the national grid? Because when you start running the numbers, the scale becomes enormous. Solar panels are surprisingly simple. Each panel contains photovoltaic cells, usually made of silicon. When sunlight hits those cells, electrons begin moving. That movement creates electricity. No steam, no moving parts, no combustion, just light becoming power. The electricity generated is direct current, or DC, and an inverter then converts this into alternating current, AC, which homes and the grid can actually use. And modern systems are dramatically better than many people realise, even in Britain, because solar panels don't need blazing Mediterranean sunshine. They just need daylight. Germany is a great example. It has installed enormous amounts of solar, despite having weather remarkably similar to parts of the UK. A typical modern UK domestic system is often around 4 kilowatts. Usually that means about 8 to 12 panels covering roughly 20 square metres of roof space. That system might generate anywhere between 3,000 to 4,500 kilowatt hours annually, depending on location, orientation and shading on the roof. For many households, that's a significant chunk of their yearly electricity bill, and especially if you pair this with batteries, EVs or smart energy tariffs. The costs have fallen enormously. A domestic system today will cost you somewhere around £5,000 to £8,000 fully installed. And add a battery to that, and this will rise, but it's going to be around the 10,000 to 15,000 mark. Still expensive, but dramatically cheaper than a decade ago. Now let's imagine that scaling nationally. Britain has roughly 28 million households. Not every roof is suitable. Some face the wrong direction. Some are shaded. Some are on listed buildings. Some are on flats. But millions are absolutely viable. Now, if we add on warehouses, supermarkets, schools, office buildings, distribution centres, and the potential becomes enormous. Estimates suggest total UK rooftop solar generation could potentially reach 120 to 150 terawatt hours every year. That's potentially close to a third of Britain's current electricity demand from rooftops alone. Now this is where the numbers become fascinating. If Britain aggressively rolled out domestic solar nationwide, the total investment would reach hundreds of billions of pounds over decades. But context matters. Britain already spends enormous sums importing energy, year after year. So the real question becomes, do you spend continuously buying fuel forever, or spend heavily once building infrastructure that produces electricity for decades? Because solar panels can continue generating useful power for 25 to 40 years. And unlike fossil fuels, sunlight doesn't arrive in tankers. A transition on this scale wouldn't just require panels, it would require an entire industrial ecosystem. We'd need factories producing panels, batteries, inverters, more transformers, better cabling. We'd also require grid upgrades, planning reform, financial systems so people can afford the solar. We'd need battery manufacturing on a huge scale and a massive increase in skilled labour, because Britain would likely need to train tens of thousands of additional installers, electricians and engineers. Because right now, installation capacity itself is one of the biggest bottlenecks. The future energy transition is not simply an engineering challenge, it's a manufacturing and workforce challenge too. The interesting thing is, this transition has already started. Britain already has millions of solar installations. Battery adoption is accelerating and EV adoption continues to grow. And huge warehouses across the country are quietly filling their roofs with solar panels. But we're still in the early days of this. Most rooftops remain unused. Most homes still don't have batteries, and the national grid was never originally designed for millions of small generators feeding power back into the system. Which means the next few decades may completely transform how electricity works, and the benefits will go far beyond any climate targets. More domestic generation would mean lower imports, less exposure to global fuel shocks, reduced strain on centralised infrastructure, and potentially lower long-term energy costs. It could also create jobs, manufacturing and engineering demand, and new industries. Because energy systems don't just power civilization, they shape economics. What makes rooftop solar truly interesting isn't just the panels themselves, it's what happens when they combine with everything else. Home batteries, electric vehicles, smart appliances, dynamic electricity pricing, AI-controlled energy systems. For more than a century, electricity mostly flowed one way, from giant power stations towards passive consumers. But the future grid may behave completely differently. Homes generating electricity, cars storing it, batteries balancing it, software managing it in real time. Not millions of consumers, millions of participants. And once you start imagining that system at a national scale, you realise this isn't just an energy transition. It may be a complete redesign of how civilization powers itself. The future of energy may not arrive through one giant invention. It may arrive slowly, roof by roof, battery by battery, street by street, until one day the grid itself becomes something completely different from what we know today. Subscribe for more videos about technology, infrastructure, economics, and the future. Thanks for watching.